In this series, we're going to talk about what Elixir is, why it's worth learning, and how to set up your environment for Elixir development. From there, we'll delve into the heart of Elixir, exploring its syntax, data types, and unique features like pattern matching and concurrency. We'll also go through Elixir's fantastic tools for development and testing, such as IEX and ExUnit. By the end of this series, you'll be equipped with the knowledge and skills to build real-world applications using Elixir. Now let's move on to the first video. Alright, so the first thing we're going to talk about is the basic syntax in Elixir. Let's start with an example. In Elixir, we can use io.puts/1 function to print the string hello world to the console. The io module provides functions for input and output operations, and puts is a function specifically used for printing texts. Now let's explore variables and assignment in Elixir. In Elixir, we can assign values to variables using the equals operator. Here, we assign the string John to the variable name and the integer value 25 to the variable age. To display the values of variables, we can use interpolation. In this example, we use the hashtag and then the curly braces syntax to interpolate the values of name and age into the string. The io.put/1 function is used for printing the string. Elixir is a functional programming language, and functions play a central role. Let's explore defining functions and organizing them into modules. In Elixir, we define modules using the def module keyword. Here, we define a module named greetings. Inside the greetings module, we define a function named hello that takes a parameter name. The function body uses interpolation to print a personalized greeting. When the hello function is called with an argument, the value is substituted in an interpolated string. We invoke the hello function using the module name greetings followed by a dot, and the function name passing in the argument Alice. One of the most powerful features in Elixir is pattern matching. It allows us to match and destructure values with ease. In Elixir, we can use pattern matching to assign values to variables. Here, we assign the element of the list 1, 2, 3, 4, 5 to the variable first, and the remaining elements to the variable rest. We can use io.inspection1 function to print the value of first and rest to the console. Alright, and that concludes our comprehensive guide to the basic syntax of Elixir. We've covered printing variables, functions, modules, and pattern matching. Now, we're going to talk about data types in Elixir. Elixir offers a rich set of data types that are fundamental to programming. Let's start with integers and floats in Elixir. In Elixir, we can assign integer values using the standard notation. Here, we assign the value of 25 to the variable age. Similarly, we can assign float values. Here, we assign the value of 1.75 to the variable height. Next, let's explore booleans. Booleans represent the truth values, true and false. In Elixir, we can assign these values to variables. Here, we assign true to the variable is true and false to the variable is false. Moving on, let's now work with strings. In Elixir, we can assign text values to variables using double quotes. Here, we assign the string hello Elixir to the variable greeting, and we assign the string Alice to the variable name. Now, let's explore atoms in Elixir. Atoms are constants whose names are their own values. In Elixir, atoms are denoted by a colon followed by the atom name. Here, we assign the atom OK to the variable status. Next, let's talk about lists. Lists in Elixir are collections of elements enclosed in square brackets. Here we assign a list of numbers into the variable numbers. Now let's explore tuples. Tuples are ordered collections of elements enclosed in curly braces. Here we assign a tuple representing a person's information to the variable person. Lastly, let's work with maps. Maps in Elixir are key value pairs enclosed in percent and then curly braces. Here we assign a map representing user information to the variable user. Right, and that concludes data types in Elixir. We've covered integers, floats, booleans, strings, atoms, lists, tuples, and maps. Understanding these data types is crucial for effective programming in Elixir. Now we're going to talk about working with lists and tuples in Elixir. Lists and tuples are fundamental data structures in Elixir that allow us to store and manipulate collections of values. Let's start by creating and accessing lists in Elixir. In Elixir, lists are denoted by values enclosed in square brackets. Here, we create a list named numbers with values 1, 2, 3, 4, and 5. Now, let's explore how to access elements in a list. To access the first element of a list, we can use the hd1 function. Here we assign the first element of the numbers list to the variable first. Similarly, we can use enum@2 function to access elements by index. In this case, we access the last element of the numbers by providing the index -1. Moving on, let's see how to modify lists in Elixir. In Elixir, lists are immutable, which means that they cannot be modified directly. However, we can use functions to create modified versions of lists. Here, we use the list.replace@3 function to replace the element at index 2 in the numbers list with the value 10. The resulting modified list is assigned to updated numbers. We didn't print anything out, so nothing's going to change, but now let's shift our focus to tuples. Tuples in Elixir are denoted by values enclosed in curly braces. Here, we create a tuple named person with values name, Alice, and 25. Now let's explore how to access elements in tuples. In Elixir, we can use the lm2 function to access elements within a tuple by providing the tuple and the element index. Here, we assign the value of the second element in the person tuple to the variable name and the value of the third element to the variable age. Lastly, let's see how to modify tuples. Similar to lists, tuples are also immutable in Elixir, but we can use the put lm3 function to create a modified version of a tuple. Here we use put lm3 to replace the value of the second element in the person tuple with the value 30. The resulting modified tuple is assigned to the updated person variable. So that concludes our exploration of working with lists and tuples in Elixir. We covered creating, accessing, modifying, and transforming lists and tuples. Understanding these operations is crucial for effective programming in Elixir. Now we're going to talk about operators in Elixir. Operators are symbols or special characters that allow us to perform various operations on data. Let's start with arithmetic operators in Elixir. Elixir provides familiar arithmetic operators such as addition, subtraction, multiplication, and division, where addition uses the plus sign, subtraction uses the minus sign, multiplication uses the asterisk, and division uses the slash. Here, we demonstrate examples of arithmetic operators to perform addition, subtraction, multiplication, and division. Additionally, we use the rem2 function to calculate the remainder of dividing 10 by 3. Now, let's explore comparison operators in Elixir. Comparison operators allow us to compare values and evaluate conditions in our code. Elixir provides comparison operators such as greater than or equal to, less than or equal to, equality, and inequality. Here, we demonstrate examples of using comparison operators to evaluate conditions and assign the results to variables. Now, let's explore logical operators in Elixir. Logical operators are used to combine and manipulate Boolean values. Elixir provides logical operators such as logical AND, which is the AND, and the logical OR, which is the OR, and logical NOT, which is the NOT. Here, we demonstrate examples of logical operators to perform logical operations and assign the results to variables. Lastly, let's dive into pattern matching operators in Elixir. Pattern matching operators allow us to match and destructure values with ease. In Elixir, we use the equals operator for pattern matching. Here we demonstrate examples of pattern matching operators by matching and assigning values to variables based on patterns. And that concludes our exploration of operators in Elixir. We've covered arithmetic operators, comparison operators, logical operators, and pattern matching operators. Understanding these operators is crucial for effective programming in Elixir. Now we're going to talk about control flow in Elixir. Control flow mechanisms allow us to make decisions and control the flow of our programs. In Elixir, we have three main constructs for control flow: if, case, and con. Let's start with the if statement in Elixir. The if statement allows us to perform conditional execution based on a condition. In this example, we have a variable age with a value of 20. We use the if statement to check if age is greater than or equal to 18. If the condition is true, we print you are an adult using the io_puts1 function. If the condition is false, we print you are underage. Moving on, let's explore the case statement in Elixir. The case statement allows us to match a value against multiple patterns and execute the corresponding code block. In this example, we have a variable language with the value Elixir. We use the case statement to match the value of language against different patterns. If language matches Elixir, we print you're coding in Elixir using io_puts1. If language matches Ruby, we print you're coding in Ruby. If no pattern matches, we use the underscore as a catch-all pattern and print you're coding in an unknown language. Lastly, let's explore the con statement. The con statement allows us to evaluate multiple conditions and execute the code block of the first condition that evaluates to true. In this example, we have a variable hour with a value of 12. We use the con statement to evaluate multiple conditions. If hour is less than 12, we print good morning, using the io_puts1 function. If hour is less than 18, we print good afternoon. If none of the previous conditions evaluate to true, we use the true as a catch-all condition and print good evening. Alright, so that concludes our exploration of control flow constructs, if, case, and cond in Elixir. These constructs provide a powerful way to make decisions and control the flow of your Elixir programs. Now we're going to talk about loops in Elixir. Elixir, being a functional programming language, doesn't have traditional loop constructs like for or while. Instead, we rely on recursion and the enum module to achieve looping behavior. Let's start with recursion in Elixir. In Elixir, recursion allows us to achieve looping behavior by calling a function within itself. In this example, we define a module named loops and a function countdown that takes a parameter n. The countdown function prints the value of n using ioputs 1. It then calls countdown recursively, passing n-1 as the argument. The recursive call continues until the base case, where n becomes less than 0 and the function terminates. Moving on, let's explore the enum module in Elixir. The enum module in Elixir provides a set of functions to work with enumerable data structures. In this example, we have a list of data with values 1, 2, 3, 4, and 5. We use the enum.each2 function to iterate over each element in the data. Inside the function, we use an anonymous function to print each element using ioputs 1. Then let's also run the other one because I forgot. And lastly, let's explore transformations using the enum module. The enum module provides functions to transform enumerable data structures. In this example, we have a list called data with values 1, 2, 3, 4, and 5. We use the enum.map2 function to apply a transformation to each element in data. Inside the function, we can use an anonymous function to double each element by multiplying it by 2. The transform list is assigned to double data. And that concludes our exploration of loops in Elixir through recursion and the enum module. Recursion allows us to achieve looping behavior by calling a function within itself, while the enum module provides powerful functions for iteration and transformation of enumerable data structures. Now we're going to talk about modules and functions in Elixir. Elixir, being a functional programming language, revolves around modules and functions. Let's start by understanding how to define a module and create functions in Elixir. In Elixir, we use the def module keyword to define a module. Here we define a module named math. Inside the module, we use the def keyword to define a function. We define a function named sum that takes two parameters a and b. The function body performs the addition operation a plus b. Outside the module, we call the sum function using the module name math and pass arguments 3 and 4. The result of the addition is assigned to the variable result. Moving on, let's explore function arity and pattern matching in Elixir. In Elixir, a module can have multiple functions with the same name but different arities or the number of parameters. In the greetings module, we define two versions of the greet function, one with an arity of 1 and another with an arity of 2. When calling the greet function, Elixir uses pattern matching to determine which function to execute based on the number of arguments provided. Here we call the greet function with one argument Alice, which matches the function with arity 1 and prints hello Alice. Then we call the greet function with two arguments, Carlos and Spanish, which matches the function with arity 2 and prints hola Carlos. Lastly, let's explore function clauses in Elixir. Function clauses. In Elixir, we can define multiple function clauses with the same name but different arities or patterns. In the calculator module, we define two function clauses for the add function. The first clause adds two numbers a and b, while the second clause adds three numbers a, b, and c. When calling the add function, Elixir matches the appropriate function clause based on the arity or pattern of the arguments provided. Here, we call the add function with two arguments, 2 and 3, resulting in result 1 being added 5. We also call the add function with three arguments, 2, 3, and 4, resulting in result 2 being assigned 9. So that concludes our exploration of Elixir modules and functions. We've learned how to define modules, create functions with different arities, leverage pattern matching, and function clauses. Elixir's module and function system gives us the flexibility to write expressive and reusable code. Now we're going to talk about pattern matching in Elixir. Pattern matching is a powerful concept in Elixir that allows us to extract and match values, destructure data structures, and make our code more expressive. Let's start by exploring how to match literal values in Elixir. In Elixir, we can use the case statement for pattern matching. In this example, we have a variable fruit with the value apple. We use the case statement to match the value of fruit against different patterns. If fruit matches the literal value apple, we print it's an apple using the ioputs1 function. Similarly, if fruit matches the literal value orange, we print it's an orange. If none of the previous patterns match, we use the underscore as a catch-all pattern and print it's something else. Now let's explore how to match tuples in Elixir. Let's go ahead and print that out first. Alright, now let's go ahead and explore how to match tuples. In Elixir, we can use matching to destructure tuples and extract their elements. In this example, we have a tuple named person with values name, Alice, and 25. We use the case statement to match the structure of person against different patterns. If person matches the pattern name, name, age, we extract the values name and age from the tuple. We then print the extracted values using string interpolation. If person doesn't match the expected pattern, we print unknown person. Lastly, let's explore how to match lists in Elixir. In Elixir, we can use pattern matching to destructure lists and extract their elements. In this example, we have a list named numbers with 1, 2, and 3. We use the case statement to match the structure of numbers against different patterns. If numbers matches the pattern 1, 2, we print the list starts with 1 and 2. If numbers matches the pattern head, tail, we extract the first element head and the remaining elements tail. We then print that the list starts with head and has additional elements. If numbers is an empty list, we print the list is empty. Now we're going to talk about structs and Elixir. Structs allow us to create custom data types with name fields, providing a convenient way to organize and manipulate data. Let's start by understanding how to define a struct in Elixir. In Elixir, we use the def_struct macro to define a struct with name fields. In this example, we define a module named person and use def_struct to define the struct with fields name and age. We assign a new instance of person struct to the variable person, providing values for the name and age fields. Or I didn't have anything to return, so that didn't run. But now moving on, let's explore how to access the fields of a struct. In Elixir, we can access, let's keep that up. In Elixir, we can access the fields of a struct using dot notation. Here, we assign the value of the name field in the person struct to the variable name. Similarly, we assign the value of age to the field variable age. Next, let's see how we can update the fields of a struct. In Elixir, we can update the fields of a struct using the percent, braces, syntax with the field and its new value. Here, we create a new struct named updated person by updating the age field of the person to 26. Lastly, let's explore how to add functions to structs. In Elixir, we can define functions within the module that defines the struct. Here, we enhance the person module by adding a greet function that takes the percent person struct and extracts the name field to print a greeting. We then call the greet function, passing the person struct as an argument. That concludes our exploration of working with structs in Elixir. We've learned how to define structs, access and update their fields, and even add functions to them. Structs provide a powerful way to organize and manipulate data in a structured manner. Now we're going to talk about binaries, strings, and char lists in Elixir. In Elixir, we have different data types to represent sequences of characters each with its own characteristics and use cases. Let's start by exploring binaries in Elixir. In Elixir, binaries are sequences of bytes enclosed in double angle brackets. In this example, we define a binary named binary with the bytes 104, 101, 108, 108, and 111 representing the characters hello. We use the ioputs1 function to print the binary to the console. The byte size 1 function returns the number of bytes in the binary, and the bin size 1 function returns the size of the binary in bits. Moving on, let's explore the strings in Elixir. In Elixir, strings are represented using double quotes. In this example, we define a string named string with the value hello. We use the ioputs1 function to print the string to the console, and the string length1 function returns the number of characters in the string. Lastly, let's explore char lists or char lists. In Elixir, char lists are represented using single quotes. In this example, we define a char list named char list with the value hello. We use the ioputs1 function to print the char list to the console, and the list.length1 function returns the number of elements or individual characters in each char list. That concludes our exploration of binaries, strings, and char lists in Elixir. We've learned about their differences, characteristics, and how to work with them effectively. Understanding these data types will help you manipulate and process text-based data in Elixir. Now, we're going to talk about understanding processes and messages in Elixir. Elixir, being built on the Erlang VM, provides a lightweight concurrency model through processes. Let's start by exploring how to spawn processes in Elixir. In Elixir, we can spawn a new process using the spawn1 function. In this example, we spawn a new process that executes an anonymous function. Inside the function, we use the ioputs1 function to print a message that includes the process identifier self of the spawn process. Moving on, let's explore how to send and receive messages between processes. Or let's go ahead and do that. In Elixir, processes communicate with each other by sending and receiving messages. Here, we use the send_to function to send a message, greet Alice, to the process identified by pin. The receiving process uses the receive construct to pattern match and handle incoming messages. In this example, we match the message pattern greet name and print a greeting that includes the name. Next, let's see how to handle unexpected messages in the receiving process. In Elixir, it's important to handle unexpected messages to avoid causing errors or blocking the process. Here, we use the underscore pattern to receive block to match any message that doesn't match the previous pattern. In this example, we print a message indicating that an unexpected message was received. Lastly, let's explore the concurrent execution using multiple processes. In Elixir, processes enable lightweight concurrency, allowing multiple processes to execute concurrently. Here, we spawn two processes, PID1 and PID2, each printing a different message. We introduce a delay using process.sleep1 to allow time for both processes to execute concurrently. So that concludes our exploration of processes and messages in Elixir. We've learned how to spawn processes, send and receive messages, and leverage concurrency in Elixir. Processes and message passing provide a powerful way to achieve concurrent and fault-tolerant systems. Now we're going to talk about testing with ExUnit. Testing is an essential part of software development, and Elixir provides a powerful testing framework called ExUnit. Let's start by exploring how to write a test case in ExUnit. In Elixir, we define test cases as modules that use the ExUnit case.case module. In this example, we define a test case module called myMathTest. Inside this module, we use the test macro to define a test case named addition. Within the test case, we can use the assert macro to verify the expression 2 plus 2 equals 4. To run a test with ExUnit, you would open up a terminal and type in mix test. Mix will automatically detect and execute all the test cases defined in the project using ExUnit. Next, let's explore some additional assertions available in ExUnit. ExUnit provides a range of assertions to validate different types of expressions and conditions. In this example, we demonstrate assertions such as equality, greater than, pattern matching, or the equals with destructing, and list difference. Lastly, let's explore setup and teardown functions in ExUnit. ExUnit allows us to define, setup, and teardown functions to perform pre-test and post-test operations. In this example, we define a test case module named database test. Inside the module, we use the setup macro to define the setup function responsible for setting up the database connection. Similarly, we use the teardown macro to define the teardown function responsible for cleaning up the database. We can then define test cases within the module that can utilize the setup and teardown functions. And that concludes our introduction to testing with ExUnit and Elixir. We've learned how to write test cases, run tests with ExUnit, and use different assertions, also leverage setup and teardown functions. Testing is crucial for ensuring the correctness and reliability of our Elixir code. Now let's talk about file and I/O operations in Elixir. Elixir provides powerful built-in functions and modules for reading from and writing to files, handling exceptions, and working with streams. Let's start by exploring how to read from a file in Elixir. In Elixir, we can read the contents of a file using the file.read1 function. In this example, we read the file example.txt and use the pipe operator to pass the result to a case statement for pattern matching. If the file read is successful, OK content, we use IO puts 1 to print the file content. If there's an error in the error reason, we print an error message with the reason. Moving on, let's explore how to write a file in Elixir. Elixir provides the file.write_to function to write content to a file. In this example, we write the string hello Elixir to the file output text using file.write_to. We then use a case statement to check if the file write is successful or if there's an error. If the write is successful, or the :OK, we print a success message. If there's an error, we print an error message with the reason. Now let's see how to handle file exceptions in Elixir. In Elixir, we can use the try rescue construct to handle exceptions that may occur during file operations. In this example, we attempt to read a non-existent file, non-existent.txt, using the file.read1 function within a try block. If an exception occurs, denoted by error, we use the rescue block to catch the exception and print a message indicating that the file does not exist. Lastly, let's explore working with file streams in Elixir. Elixir provides the file.stream1 function to create a stream from a file. In this example, we create a stream from the file large file text using the file.stream1 function. We use the stream.take2 function to limit the stream to 5 lines. Finally, we use the enum.each2 function with the io.inspect1 function to print each line of the stream. Alright, that concludes our exploration of file and I/O operations in Elixir. We've learned how to read from and write to files, handle exceptions, and work with file streams using Elixir's built-in functions and modules. File manipulation is an essential aspect of many applications, and Elixir provides powerful tools to handle file-related tasks effectively. Now, we're going to talk about concurrency and parallelism in Elixir. Elixir's concurrency model, based on lightweight processes and message passing, enables us to build highly concurrent and scalable applications. Let's start by exploring how to spawn processes in Elixir. In Elixir, we can create lightweight processes using the spawn1 function. In this example, we spawn 2 processes, pid1 and pid2, each executing an anonymous function that prints a message. We introduce a delay using process.sleep1 function to allow time for both processes to execute concurrently. Moving on, let's explore how to pass messages between processes in Elixir. In Elixir, processes communicate with each other through message passing. Here we spawn a new process, pid, that waits for a message using the receive construct. We use the send_to function to send the message hello from the main process to pid. The receiving process pattern matches the message and prints it. Now, let's explore task-based parallelism in Elixir. Elixir provides the task module to execute tasks concurrently. In the example, we define task 1 and task 2 using the task.async1 function, which creates tasks that run in parallel. Each task executes a long-running task using the anonymous functions. We use the task.await1 function to await for the completion of each task, ensuring parallel execution. Lastly, let's explore parallel map using task.async stream3. Elixir provides the task.async stream3 function to perform parallel operations on a collection. In this example, we have a list of numbers and use the task.async stream3 function to apply the expensive calculation function to each number in parallel. We use the stream.map2 function to map the results of the tasks and the enum.each2 function with io.inspect1 function to print each result. This concludes our exploration of concurrency and parallelism in Elixir. We've learned how to spawn processes, pass messages between processes, utilize task-based parallelism, and perform parallel operations using task.async stream3. Elixir's lightweight processes and powerful concurrency model enable us to build highly scalable and concurrent applications. Now we're going to talk about protocols in Elixir. Protocols are a powerful mechanism in Elixir that allow us to achieve polymorphism and write flexible, extensible code. Let's start by exploring how to define a protocol in Elixir. In Elixir, we use the def protocol macro to define a protocol. In this example, we define a protocol named JSON-able. Inside the protocol block, we use the def macro to define the function toJSON1. Moving on, let's explore how to implement a protocol for different data types. To implement a protocol for a specific data type, we use the def impl macro followed by the protocol name and the for keyword, specifying the data type that we want to implement the protocol for. In this example, we implement the JSON-able protocol for the atom and list data types. For the atom implementation, we define the toJSON1 function that converts the atom to a JSON string. For the list implementation, we define the toJSON1 function that recursively converts each element of the list to JSON and joins them with commas. Next, let's see how to use the protocol in our code. Once we have defined a protocol and implemented it for specific data types, we can use it just like any other function. In this example, we use the toJSON1 function, which is part of the JSON-able protocol, to convert an atom and a list to JSON. We use the io.puts1 function to print the JSON representation of the data. Lastly, let's explore how to consolidate protocols by implementing them for more data types. Protocols in Elixir can be consolidated by implementing them for additional data types. In this example, we consolidate the JSON-able protocol by implementing it for the tuple data type. We define the toJSON1 function that converts the tuple to a JSON string by recursively converting each element and joining them with commas. So that concludes our exploration of Elixir protocols. We've learned how to define protocols, implement them for specific data types, and use them to achieve polymorphic behavior in Elixir. Protocols provide a flexible and extensible way to write reusable code in Elixir.